Hello, now again I am back with another set of my video on acids, bases and salts, right? So in our previous videos we discussed about what acids are, what are strong and weak acids, and then what are concentrated and dilute acids and how are we supposed to dilute the acids and all such things we discussed, right? Now, if you are given two substances and both of them look very similar, maybe two colorless liquids you are being given, and I ask you to identify which is acid and which is base. It is very dangerous to taste every thing like what you see, right? So you definitely cannot drink it or taste it and find out whether it is sour or bitter. So what are we supposed to do? We basically find out whether something is acid or a base with the help of substances called as indicators. Now these indicators, they basically identify an acid or a base by changing their original color in acids or base, or they might even change their smell. So when we talk about indicators, we have two types of indicators, natural and man-made indicators. Now when we talk about natural indicators, we have turmeric, beetroot, red cabbage, vanilla, onion, litmus, all these are natural indicators. Okay, so when we use turmeric, now turmeric, it's a very common household item and we all know its color is what? Yellow. Okay, you take some lime and you mix it with turmeric and you will see the change in color. This is something very common even in you can do it. It is very easily available. You can go to any palm shop and get a little bit of lime and you can mix it with turmeric and you'll see that it turns red in color. So basically turmeric turns red in base. Then beetroot. We all are aware of the color of beetroot. Okay. A magenta color, you can say, So you can take this beetroot extract, you can boil beetroot in water and you take that extract out of beetroot and add a little bit of base in it and it will turn purple in color. It will turn purple in color. Then we have the red cabbage. Now the red cabbage is almost, the color is like that of beetroot only, and red to purple it is in acid, but it will basically change to yellowish color in base. Okay. Similarly, we have vanilla and onion. Now vanilla and onion, they don't change their color. What happens? They have a very strong smell, vanilla and onion, right? But when you add them in a base, they lose their smell. So such type of indicators are called olfactory indicators. Okay. Then I'll talk about litmus also. Litmus is actually a purple colored dye which we extract from a lichen. Okay. Now this purple dye, it turns red in acid and it turns blue in base. Okay, so what you can do is you can make a solution of litmus or you can take some litmus dye, the purple dye, add acid in it and it will turn red. Okay, it will become a red solution. Then you can cut strips of filter paper and you can dip it in it and then take it out and it will become red litmus paper. Similarly, you can make blue litmus paper also out of it. So these litmus papers are very handy and you can test acids and bases with the help of these litmus paper. Okay, so otherwise it's a purple colored dye. Right. Then we come to man-made indicators. We have phenolphthalein, we have methyl orange, and we have the universal indicator. Okay, so I will just talk about these three. I'm just rubbing this. Okay, now let us discuss about this first, that is phenolphthalein, right? Now phenolphthalein is basically colorless in neutral and acidic solution. So it is colorless in neutral and acidic solutions. Okay, so when you get phenolphthalein, you will get it as a colorless liquid. Okay, but the moment you add it in base, it will turn pink in base. Very important. Okay, so it will give a pink color in base. It's a basic indicator. So the moment you add base to it, it will turn pink in color, and thus it will indicate that okay, this thing is a base. Otherwise, it will remain colorless. Right? Okay. Now let us come to the other one. That is the methyl orange. I hope this is clear. Okay. Now. Now let's talk about this methyl orange. Okay. Methyl orange. Okay. So it is got an orangish red color. Okay. So basically it is yellowish, a very yellowish orange, yellow in neutral and base. So okay, in base and in neutral solutions it is yellow in color, but it will turn deep red in acids. Okay, so in acids it will give a deep red color, methyl orange. Okay, right. Then let us talk about the universal indicator. Now this is very important. Universal indicator even indicates whether what is the strength of that acid or a base. Okay, later on in this chapter I'll be discussing about the pH also, the pH value. This is what the universal indicator usually indicates. Now this is very important to know how strong an acid and a base is. Okay, so usually when in a neutral solution it is green in color. Okay, it is green in color, neutral, in a neutral solution. But in acid it will turn yellow, orange and ultimately red in acid, and it will turn like purple, very purple color in violet or purple color, right? Violet or purple in a base. Okay, so in between there is variation. There is a variation of colors. So like for example, green to yellow, and then to orange, and then to deeper orange, and then ultimately to red. Similarly, green to again towards the various shades of blue, and ultimately it will turn to purple, right? So this way the universal indicator also indicates whether something is acidic or basic, and the strength also, right? But it is green in neutral solution. Is it clear to everyone? Okay, fine. So I have two questions for you, right? The very first question is, there are compounds like glucose and alcohol. Okay, they contain hydrogen, but they are not acids. Why? Please note down these questions. Glucose and alcohol. I'll just write down. This is ethanol, and this is glucose. Okay, this is ethanol, this is glucose. They both contain hydrogen, yet they are not acids. Why? This is the first question. Okay. Second question is, do acids conduct electricity or not? Or it can be asked in another way as to why do we add a little bit of acids in water when we want to pass electricity through water during the breakdown or decomposition of water. Okay, this is the second question. And the third question is, dry litmus paper is there, and when we pass this or when we take dry litmus paper towards HCl gas, okay, HCl gas, and we are taking dry blue litmus paper towards this HCl gas, do you expect a change in color of the litmus paper? Why or why not? Okay, so these are the 3 questions. I want you all to think about it. In my next video, I will be talking about the chemical properties of acids, and I will be telling you about bases as well.